Hey guys, okay, so this is how to transform rational functions. This will be on your test. It's also on your review. So the rational function parent graph is going to be y equals 1 over x. And if you type this into your calculator, you're going to notice that your graph is here and it's here. So the reason that this graph has such a funny shape is that it has what's called vertical asymptote and a horizontal asymptote. So in case you don't remember, an asymptote is a line that the graph will approach but not cross. So there's one asymptote here, and there's one asymptote here. And so basically what happens is that those lines end up cutting the graph into two pieces because they're not allowed to connect with each other because neither of them can cross over that line. So your vertical asymptote here is this one, x equals 0. And your horizontal asymptote is this one, which is y equals 0. So in case you remember from Algebra 1, you have Hoy-Vux. So horizontal is the h in Hoy, and then y is the y equals. Then for Vux, it's vertical, and it's x equals here. So if that helps you remember which one's which, then think about that. Okay, so your domain is going to be from negative infinity to 0, and then from 0 to infinity. This is why. On this side, your graph goes back forever and ever and ever and ever. But when it goes this way, think about your x's. It gets closer and closer to 0, but since it's not allowed to touch this blue line, it never actually gets to 0. That's why we leave this as a parentheses instead of a bracket. Then you have this other half of the graph over here. Well, it goes forward to infinity, but on this side, it's getting closer and closer to 0, but it never actually gets there. Okay, same thing with the range. This side goes down forever and ever. This side goes up forever and ever, but this blue line right here, it's not allowed to cross. So because your graph is in two pieces, your domain and range are in two pieces as well. Okay, now transforming these or translating these follows the exact same rules as any other translation that you've pretty much ever done. So for example, if I'm looking at number 1 down here, okay, notice that this was the parent graph because it didn't have any extra numbers in it. But if I put a plus 3, that shifts me to the left 3. And then if I put a minus 1, that shifts my graph down 1. So I would go to the left 3, 1, 2, 3, down 1, that puts me right here. And then I'm going to redraw those asymptote lines in through that point. So 1 goes here, 1 goes here. And then remember that my graph has to stay close to those lines, but it's not going to ever actually cross through those lines, okay? Then if I were to label those, this one over here is y equals minus 1. That's your horizontal asymptote, okay? Horizontal asymptote. But then this one right here is my vertical asymptote, and that's at x equals negative 3, okay? Then your domain, if I think about x's, okay, well, where does my graph split? My graph splits right here. That's at x equals minus 3. So I'll go negative infinity to negative 3, union negative 3 till infinity. Okay, then for my range, if I think about up and down, okay, this side goes down forever, but it stops when I hit this flat line, which is at negative 1. So negative infinity to negative 1, union negative 1 till infinity. Okay, take a look at number 2. I have a minus 2 down here. That's going to shift me to the right 2. I have a plus 6 here. That's going to shift me up 6. So I'm going to go to the right 2, up 6. That puts me right here. And then I'm going to draw in my line across and my line up and down. Okay? Remember that those are horizontal asymptotes. This is your HA. This is your VA. Okay? Your HA is a horizontal line through 6. So that would be y equals 6. And then your VA is cutting through x equals 2 right here. So x equals 2. Then from there, if 2 is the number I can't cross, that's the number that my domain is going to be broken up around. So it'll be 2 here and 2 here, because that's the line. Oops, I forgot to actually draw my graph. But it will be here, and then it will be here. Okay, and so remember that your graph is getting really close to this side. It's getting really close to this side down here, but it's not actually touching either of those lines. Okay, then for my range, this side goes down forever, but when it gets up to here, it never actually can get to 6. So I do negative infinity till 6, union. And then this side goes down forever towards 6, but it's never going to actually touch 6. But then the other side goes up forever. Another way that you can think about it is that, remember, your domain is x, that's why you're using the x equals. Your range is y, that's why you're using the y equals 6 to split it up. Okay? And then if you come up here to these little blanks that we skipped, you'll notice that if the graph is shifted left or right, this is actually going to move the up and down, or the vertical line. Okay, so for example, when I moved to the left 3, this line is the one that moved over 3. It was here and it went 1, 2, 3. Okay, versus this one, I had a -2, so that shifted that line forward 2. Okay, then when I move it up or down, I'm moving this flat line. That's your horizontal asymptote. So that might seem kind of backwards to you, but whichever way you move it, that moves the vertical asymptote if it's side to side, or it will be shifting the horizontal asymptote. So like here I had a -1, that's why I moved my flat line down 1. This one I had a +6, so I moved my flat line up 6. Okay? Alright, turn over to the back for me, please. Got a couple more of these left. Okay, taking a look at number 3, I have a -5. That means that I'm going to move to the right 5. Then I have a +2. That's going to move my graph up 2. So 5, 2, boom, right there. Okay, then I'm going to draw in my asymptotes. I have one straight across at 2. Then I have one up and down here at 5. Remember that this one is my VA, this one is my HA. Remember, the difference is just that vertical is up and down, horizontal is across. Okay? From there, let's draw our graph. Normally, my graph would be here and here, just like we drew the other ones. But hopefully you notice that on this one, because you have a negative in the front, the negative is going to flip the graph down. So instead of my graph being up here, I'm going to graph it down here. Okay? Now, on this side, my graph would have been down here, but it actually flips my graph up. And the reason why that is that if I'm flipping something that started on the bottom, it's going to end up on the top. Remember, that's how reflections work. Okay? My horizontal asymptote is here, which is cutting through y equals 2. My vertical asymptote is here, which is cutting through x equals 5. Then my domain will be negative infinity until 5, union 5 to infinity. Because remember, if that's my x value, domain is x. And then range is going to be broken up around my horizontal asymptote, which is at 2. So it'll be negative infinity to 2, union 2 to infinity. Okay? Take a look at number 4. I have this +4 at the back. That's going to move my graph up 4. But then I notice that down here with x, there's not a number there. That means that I'm not going to move it side to side at all. So I'm only going to go up 4. So you don't have to move the graph side to side. If there's not a number down here with the x, then you're not going to see a side to side movement in where your asymptotes go. Okay? So there's my graph. Remember, this is my HA, this is my VA. And then normally I would have my graph be in this top corner and this bottom corner. However, again, you should notice you have that negative in the front and that flips it. So instead of being in these two corners, you're going to be in these two corners. So I'll have one down here and then I'll have 1 up here. Okay. Then from there, my HA is at y equals 4. And my VA, since I kept it right here in the middle, that's going to count as x equals 0. Then from there, your domain is going to be from negative infinity until, remember my x here was a 0, and then 0 to infinity. My range will be from negative infinity down here going forever until 4. And then from 4 till infinity. Okay? All right, we have one more left with the graph, so go down to number 5. Okay, number 5 says find the center of the rational function graph to the right, then identify the HA and the VA. So if I'm looking at my graph here, I need to try to fit a line into the graph so that it doesn't touch either side of my graph. So I see this one here and this one here, and I can't touch those. So I need to try to slide a line in between these. Well, on this side, it looks like I'm getting really close to 2. And then I notice that if I draw it on the other side, it's not actually touching my blue line. That's my HA. That's at a height of 2, so I'm going to put y equals 2. Then for my VA, I need to draw in a vertical line that's going to perfectly sandwich between those two sides. So I see up here that it looks like I'm approaching 1, and then down here it looks like I'm approaching 1 as well. So that would be x equals 1. Now, how do I know that it's x equals? Because remember, that's your Hoy Vux, right? This is your Hoy, horizontal, H-O-Y. This is your Vux, V-U-X. Okay? From here, I'm going to draw my center, which would be here. That's over 1 and up 2. Which means that the equation for my graph would be 1 over, if I want to go to the right one, I need to do x minus 1. And then if I want to go up 2, I have to put a plus 2 in the back. Okay? My domain is going to be broken up around 1, because that's what my x value is here. So it'll be negative infinity to 1, union 1 to infinity. My range is broken up at y equals 2, so that would be negative infinity to 2, union 2 to infinity. And you should be able to tell that based on your graph there. Okay? Alright, last little section down here. So if I'm looking at the next one, on your test there are going to be several questions that ask you about the HA and the VA, but they're not going to actually make you graph it. So what you should know is that the way that you shift these determines where your asymptotes end up. So if I have a minus 17 in here, that's going to shift my graph to the right 17. That's going to make my VA a positive 17. X equals positive 17. Okay, then for my plus 1, that's going to move my graph up 1. Well, that's going to affect my flat line. And so if it's up 1, that would be y equals 1. So remember that this number in here is going to tell you the x equals, and this number here is going to tell you the y equals. Now keep in mind the x is always opposite, right? Okay, this one has a plus 12. That means I'm going to the left 12. So my VA would be x equals minus 12. Then I have a minus 13 here. That's going to give me a down 13. So I would do y equals negative 13. Okay? Now, for these last two down here, there are not any like this on your test, but if you have a description of what should be happening, then you should also be able to write the equation. So for example, if I'm doing this one, I want to reflect my graph, and I want to translate it up 9. Then I would do negative f of x, and then plus 9. And notice that I want to keep the plus 9 outside of the x to show that it's an up 9. Okay? So let's look at the one before that. I want to go to the left 3 and up 6. So that'd be f of x plus 3 if it's a minus, because I want to go to the left 3. And then if I want to go up 6, that's a plus 6. Now, I want to draw your attention to one other thing. Notice that this one is flipped across the x-axis. That's the way that you're used to flipping it. This one we want to reflect across the y-axis. So think about it. If I had a graph, let's say, I don't know, that it's here, right? Normally, when I'm flipping across the x-axis, which is this one. And so I would take my u that's facing up and I would flip it so that it's facing down. This one is asking you to flip across the y-axis. This is the y-axis. So if I want to flip from here to here, I am still going to use a negative, but hopefully that you remember the negative doesn't go on the outside, it needs to go on the inside. Okay, so I'm going to put right here a negative on the inside flips backwards. Okay, and that's a detail that you should remember from when we did square roots, but if you forgot, oh well, not the end of the world. Okay, so that is how you graph rational functions. There's a separate video for the first half of the review, so if you want to watch that, you can look at that video. Okay, good luck.